What if I told you that machines are getting closer not just to understanding our commands, but to moving like us, reacting like us, maybe even thinking like us? At Stanford University, inside one of the world's leading robotics labs, something quietly revolutionary is happening. Researchers have made a breakthrough that could push robots beyond automation and into the territory of embodied intelligence. This isn't about walking robots that look like humans or sci-fi androids. This is about something far more subtle and far more powerful: dexterity. Now, that word dexterity might not sound thrilling, but think about what it really means. It's the ability to manipulate the physical world with nuance. It's the smooth turn of a wrist, the careful threading of a needle, the way your hand knows, instinctively, how hard to grip a ripe peach without bruising it. For decades, this has been a robotic Achilles heel. Industrial robots can lift a car door or weld steel with superhuman precision. But ask them to tie a shoelace, to crack an egg, to gently dress a wound? They can't. At least, not until now. Stanford's new system doesn't rely on traditional programming. You see, most robots up until now were built on rigid logic: if this, then that. Every movement had to be manually coded. That's fine when you're on a predictable factory line. But real life is messy, it's unpredictable. And that's where this new approach changes everything. Instead of programming behavior, Stanford's engineers are training their robots. They're using neural control models and reinforcement learning AI systems that learn through trial and error. These robots don't just follow commands, they practice. They experiment, they fail, and they improve. It's not unlike how a toddler learns to hold a spoon. There's no manual for it, just the body, the brain, and repetition. The robot learns by doing, and over time its movements become more natural, more fluid, more human. It's a quiet evolution, but one with massive implications. Imagine a robot in a hospital room, helping a patient get dressed after surgery. One in your kitchen, chopping vegetables for dinner. One in a disaster zone, carefully navigating rubble to pull someone from danger. These aren't science fiction fantasies anymore. With dexterous control, robots gain access to environments that were once off limits, not because they were too dangerous, but because they were too complex. But here's where the story takes a turn, because as these machines become more physically capable, we're forced to confront questions that go beyond engineering, beyond technology. We have to ask, what happens to us? If a machine can do everything a pair of skilled hands can do faster, longer, and without rest, what does that mean for the people who've built their lives around those hands? Jobs in caregiving, in construction, in food preparation, in manufacturing. These aren't just professions, they're identities. And the fear isn't just about replacement, it's about displacement. It's about what happens when we begin to trust machines with the very tasks that make us feel human: nurturing, healing, building, feeding. There's another layer too, one that's even more intimate. When a robot can touch gently, move smoothly, and respond intelligently, the line between tool and companion begins to blur. Would you let a robot care for your aging parent? Would you accept one as a surgical assistant? Would you feel comforted by it, or quietly unsettled? Stanford's researchers are aware of these questions. They don't claim to have all the answers, but they believe this: the future of robotics isn't about replacing people. It's about building machines that can work alongside us, machines that augment our strengths, not erase them. And perhaps that's the most important shift, moving away from fear and toward designing with intention. Because the truth is, this technology is coming. The ability to teach machines how to move like humans, it's no longer a matter of if, it's a matter of how we use it. We stand at a crossroads. One path leads to a world where dexterous machines make life easier, safer, more humane, where robots care for the vulnerable, assist the overworked, and take on the tasks we no longer want or need to carry. The other path, a world where profit outruns ethics, where automation creeps silently into every corner, displacing people in the name of efficiency, without regard for dignity, where machines don't just reflect our intelligence but our indifference. Stanford's breakthrough is more than a technical achievement. It's a mirror. It shows us what's possible when we teach machines to understand the world as we do. But it also asks, are we ready to share it with them? Dexterity was once uniquely ours. The subtlety, the feel, the grace of movement honed over millions of years of evolution. Now, that gift is being given to machines. What they do with it will depend on us, and the most human move we can make may be deciding, carefully, where we want these robots to stop.